Now that we've got a handle on mathematical induction, we're going to add a new and very similar technique. The principle behind this method, called strong induction, is very similar to what you saw with regular mathematical induction, which is often called weak induction to help distinguish the two methods. They both start off the same way, proving a base case or a base step. And as we saw in the previous examples, this is usually going to be 0 or 1, but it could from time to time be something else. The inductive step is where things get different, and the technical language here is a little cluttered. But what this is saying is that instead of just assuming the theorem is true for n and then showing it's true for n plus 1, we're going to assume that it's true for every value between that initial value from the base case all the way up to n, and then show that it's true for n plus 1. In contrast to strong induction, you'll sometimes see regular mathematical induction referred to as weak induction, which I mentioned earlier, or sometimes as incomplete induction. I'll usually just stick to calling it mathematical induction, and I definitely avoid the incomplete label since it isn't really accurate. Regular mathematical induction is a perfectly complete and usable mathematical technique. So incomplete is just a really poor choice of words for it. And in the next lectures, we're going to look at several examples of proofs using this new technique. And we'll wrap up with a look at the relationship between mathematical induction, strong induction, and the well ordering principle.